Imagine Earth 4.5 billion years ago. It wasn't the vibrant planet we know today. Picture a chaotic molten world. Volcanoes erupt, spewing lava and gas. Asteroids bombard the surface, leaving massive craters. This was Earth in its infancy, still forming in the vastness of space. But even before Earth, there was something else. A giant swirling cloud of gas and dust. This cloud, called a nebula, was immense. It stretched for light years across the cosmos. This nebula was the birthplace of our Sun and all the planets in our solar system. Within this swirling cloud, gravity was at work. Tiny particles of dust and gas, drawn together by their mutual attraction, began to clump. Over millions of years, these clumps grew larger and larger. They pulled in more and more material, increasing their gravitational pull. Eventually, one particular clump began to dominate. This clump, destined to become our Sun, gathered more and more mass. As it did, its core became denser and hotter. The stage was set for the birth of a star. Deep within the heart of the collapsing cloud, the temperature and pressure soared. Hydrogen atoms, forced together by the immense gravity, began to fuse. This fusion, a process that powers all stars, released an incredible amount of energy, and with that, our Sun ignited. The Sun's birth was a dramatic event. Powerful solar winds blasted out from the newborn star. This wind swept through the remaining gas and dust, pushing it outward. But not all the material was blown away. The leftovers, the remnants of the Sun's formation, would eventually become the planets, asteroids, and comets of our solar system. Around the young Sun, a swirling disk of debris formed. This disk, called a protoplanetary disk, contained all the ingredients needed to make planets. There were rocky particles left over from the nebula's dust. There were gases like hydrogen and helium that hadn't been swept away by the solar wind. And there were ices, frozen water, and other volatile compounds farther out from the Sun's heat. Within this disk, the process of planet formation began. It's a process called accretion, and it's a bit like building a snowman. You start with a small snowball, then you roll it around in the snow. As it rolls, it picks up more snow, getting bigger and bigger. And that's what happened in the early solar system. Tiny grains of dust bumping into each other in the protoplanetary disk stuck together. These tiny clumps, held together by static electricity, were the seeds of planets. As they moved through the disk, they attracted more dust and gas, growing larger. Over time, these growing clumps became planetesimals, small, rocky bodies up to a few kilometers across. The solar system at this stage was a chaotic place. Thousands of planetesimals, drawn by gravity, zoomed around the Sun. They collided with each other, sometimes shattering into pieces, sometimes merging to form larger bodies. In the inner solar system, where the Sun's heat was most intense, only rocky material could survive. This is where the terrestrial planets, Mercury, Venus, Earth, and Mars formed. Farther out, beyond the frost line, ices could also condense. This allowed the gas giants, Jupiter and Saturn, to grow to enormous sizes. The process of accretion continued for millions of years. Gradually, the number of planetesimals decreased as they combined to form the planets we know today. Earth, still in its early stages, was a hot, molten world. The energy from all those collisions, along with the heat from radioactive decay within its interior, kept Earth in a molten state. But Earth wasn't done forming yet. In a final dramatic event, a Mars-sized object slammed into the young Earth. This impact, known as the Giant Impact Hypothesis, was a defining moment in Earth's history. It reshaped our planet and gave us our moon. The impact was cataclysmic. The Mars-sized object called Theia slammed into Earth at an angle. The energy released was unimaginable. Both Theia and a large chunk of Earth's mantle were vaporized. Debris from the impact was blasted out into space, forming a ring around the Earth. Over time, this ring of debris coalesced. Gravity pulled the particles together, just like it did during the formation of the planets. Gradually, a new celestial body emerged, our moon. The Moon's formation had profound effects on Earth. The impact tilted Earth's axis, giving us our seasons. It also stabilized Earth's rotation, preventing wild swings in our climate. And the Moon's gravitational pull created tides, which played a crucial role in the development of life. Section 5. From fire and ice, oceans and atmosphere emerge. After the Moon's formation, Earth began to cool. The molten surface solidified, forming the first crust. But Earth was still a violent place. Volcanoes erupted across the planet, spewing lava and gases into the atmosphere. These volcanic gases, primarily water vapor, carbon dioxide and nitrogen, formed Earth's early atmosphere. This atmosphere was very different from the one we breathe today. It was thick and hot, with no free oxygen. Water vapor, released by volcanoes and delivered by icy comets bombarding the young Earth, began to condense as the planet cooled. Rain fell from the sky, filling the first oceans. These early oceans were acidic and hot, but they were the cradle of life. The early Earth was a harsh and unforgiving place, but within this primordial soup, life found a way to emerge. The stage was set for the next chapter in Earth's incredible story. Section 6. The spark of life in a primordial soup. The exact details of how life arose on Earth remain a mystery. But we know it happened remarkably early in our planet's history. Within the primordial oceans, organic molecules, the building blocks of life, assembled. These molecules, perhaps concentrated in shallow pools or around hydrothermal vents, began to interact. Over millions of years, these interactions became more complex. Eventually, self-replicating molecules, the precursors to DNA and RNA, emerged. These molecules able to copy themselves were the first life forms. These early life forms were simple, single-celled organisms similar to bacteria. They thrived in the harsh conditions of the early Earth, extracting energy from chemicals in the environment. For billions of years, these simple life forms were the only inhabitants of our planet. But life was about to undergo a dramatic transformation. A new process, photosynthesis, would change the course of Earth's history. Section 7. The Great Oxidation, a breath of fresh air. Around 2.5 billion years ago, a new type of organism evolved. Cyanobacteria. These tiny organisms possessed a remarkable ability. They could harness the energy of sunlight to produce their own food. This process, called photosynthesis, released oxygen as a byproduct. At first, the oxygen produced by cyanobacteria reacted with iron in the oceans, forming rust. This rust settled on the ocean floor, creating vast iron ore deposits. But eventually, the oceans could absorb no more oxygen. Oxygen began to build up in the atmosphere. This was a catastrophic event for many life forms. Oxygen was toxic to them, and many went extinct. But for others, oxygen was an opportunity. It allowed for the evolution of more complex life forms that could use oxygen to produce energy. This event, known as the Great Oxidation Event, was a turning point in Earth's history. It paved the way for the evolution of all complex life, including us. Section 8. Shifting sands of time. Continents on the move. While life was evolving in the oceans, the Earth's surface was also undergoing dramatic changes. The Earth's crust, broken into massive plates, was on the move. These plates, floating on the semi-molten mantle below, collided, separated, and slid past each other. These plate movements, known as plate tectonics, shaped the Earth's surface. They created mountains, valleys, and volcanoes. They also caused the continents to drift across the globe. Over billions of years, the continents have come together and broken apart multiple times. They've formed supercontinents like Pangaea, only to break apart again. These continental movements have had a profound impact on life, driving evolution and shaping the distribution of species. Section 9. A planet in perpetual motion, Earth's continuing story. Today, Earth is a vibrant, dynamic planet. The continents are still on the move, albeit at a pace too slow for us to notice. Volcanoes erupt, reminding us of the powerful forces at work within our planet, and life teems in every corner of the globe, from the highest mountains to the deepest oceans. Earth's story is far from over. Our planet is constantly evolving, shaped by geological processes and the ever-evolving web of life. As we continue to explore our planet and beyond, we're sure to make new discoveries that will rewrite our understanding of Earth's epic journey through time. The future of Earth and our place in its story is still being written, and that's a truly awe-inspiring thought.